Hello everyone. Today we are still working with triangles. Remember, we're going to be doing that for a while. Today we're going to talk about congruent parts of congruent triangles. So let's look at what that might mean. So for example, if we have two congruent stick figures, what would that look like? Well, I would need to draw two congruent stick figures. So those are pretty close. Stick figure, some little arms, little legs, little legs. Close enough. So these two guys are congruent, kind of like twins. Now what about two congruent segments? So segments are a little bit more specific and not nearly as funny. So if I were to draw a segment, then if I were going to do a congruent one, I could just clone it. And now I have two that are congruent. So if this were A, B, and this were C, D, I know they're congruent because I cloned them, so therefore I would put my congruent marks, and I would say that AB is congruent to CD. Now what about two congruent angles? So I had two congruent angles. So I could draw a ray going that way and a ray going that way. That would be, and then I'm going to group these two together, and now I'm going to, guess what? Clone that angle. Now I have two congruent angles. Oops. And I would need to group those two as well. So now I have two congruent angles. So this would be, we'll call this angle E, and we'll call this one angle F. So two congruent angles, if they're congruent, make sure you put those congruent marks. Angle E is congruent to angle F. Then if we have two congruent triangles, so I'm going to go up here and I'm going to draw a little triangle. And then guess what I'm going to do? If I want it to be congruent, then I'm going to clone it. So now I have two congruent triangles. So now I'm going to call this triangle A, B, C, and I'm going to call this one D, E, F. So I would say triangle A, B, C is congruent to triangle D, E, F. And I know they're congruent because I cloned them, so therefore they are equal. All right, so now corresponding parts of congruent triangles are congruent. In other words, if your two triangles are congruent, like the two I just drew, that means all of their parts are congruent. So let's look at this triangle given triangle rat boy. Triangle rat is congruent to triangle boy. So this is how I do these. Instead of trying to remember the order of the letters, I assign a number because it's easier to look at. So if I called this 1, 2, and 3, so actually let me go back up here. Scratch that. Hope you're using a pencil so you can erase it. So I'm going to start up here. I'm going to say this is 1, this is 2, this is 3. Since R is 1, then B is 1. 2, and 3. So now 1, 2, 3 is congruent to 1, 2, 3. This is so much easier than trying to rearrange your letters. So now go down here to my picture. R is 1, A is 2, T is 3, B is 1, O is 2, Y is 3. So now all I got to do is match up the numbers. If angle R is 1, then angle B is congruent because it's also a 1. Angle A is congruent to angle O. Angle T is congruent to angle Y. Okay, this will make a whole lot more sense when the triangles are overlapping, and you'll see what I mean in a minute. So now, if I'm going to talk about sides, so let's say I talk about side RA. Well, RA is 1, 2. So that means RA is congruent to BO. So I'm going to put congruent marks on those two. And I knew A and O were congruent already because they're both right angles. All right angles are always equal. Now what about 2, 3? AT. AT. Then 2, 3 over here is OY. And what about 3, 1? TR. 3, 1. YB. So that means these two are congruent and these two are congruent. Notice they all three have different marks. So now how would I do that without a picture? Well, that's where it's real handy to have the 1, 2, 3, 1, 2, 3. So now I know that the 1's go together, the 2's go together, and the 3's go together. The 1, 2's, the 1, 2's, and so on. So if I talk about angle M, then that means since M is a 1, then D is a 1. The order that these are written, this is your congruence statement, are extremely, extremely important. So now angle O is congruent to angle A. Angle N is congruent to angle Y. So my 1's, my 2's, and my 3's. So now 1, 2, MO, DA. 2, 3, ON, AY. And 3, 1 would be NM, 3, 1, YD. Okay, so that's how we look at corresponding parts of congruent triangles are congruent. If my two triangles are congruent, then all of their parts are also congruent. And there are 6 parts. Okay, there are 6 parts because there's 3 sides and 3 angles. So if I'm going to write a congruence statement for this triangle, so I would look at 1, 2, 3. So 1, 2, 3. So now see how angle 1 has 3 marks? Well, I'll look over here. That one has 3 marks, so that's also a 1. This one has 1 mark, so this one gets a 2. So that means these two are going to be congruent because they have the same marks. So now look at the letters, PGT. So what is congruent to PGT? A, Q, R. A, Q, R. So triangle PGT is congruent to AQR. And it makes a whole lot of sense when they're facing the same direction, but sometimes they're all twisted around. So we have some shortcuts that we can use to prove that triangles are equal. First of all, if I tell you 3 sides are congruent to 3 sides, then guess what? Triangle RAT is congruent to triangle YOB. Okay, I know that RA goes with BO. Okay, so I'm going to call this 1, 2, and 3. So since the side with 1 mark gets 1, 2, then 1, 2. The side with 2 marks gets 2, 3, so 2, 3. So now I could say triangle RAT. Notice these were twisted a little bit. Is congruent to triangle. So what's R, B, O, Y? Okay, so these are flipped also. So I could go up here and I'm going to call this one 1, 2, 3. So the side with 2 marks, 2 marks. So see the right angle is a 2, so this right angle is a 2. So that makes that a 1 and that a 3 also. So now, this one is called side, angle, side. See how they give me a side, and then there's this angle that's in between. See how the A is in between the S's? See how the angle is in between the sides? So this one is side, angle, side. Side, angle, side. The next one is called angle, side, angle. See how the S is in between the angles? Well, see how I have these 2 angles? I have angle 1 and angle 2. See how the side is connecting them? So this would be angle, side, angle. Angle, side, angle. And then we have angle, angle, side. Now see how the side is at the end? Well, I've got 2 angles, and then the side that's not connecting them. 2 angles, and the side that's not connecting them. So that would be angle, angle, side. So it's all about the placement. If the S is in the middle, then the side is in the middle. If the S is at the end, then the S is not in the middle. Then we have the hypotenuse leg. This only works on right triangles. Only right triangles. And the H is for hypotenuse, and L is for leg. So since I have an angle and an angle, I know they're both 90 because all 90-degree angles are the same. So they give me a leg, and they give me the hypotenuse. So this one is hypotenuse leg. Now there's 2 shortcuts that do not work. That's side, side, angle. And yes, it does say what you see in reverse. Or angle, angle, angle. These 2 will not work, okay? I call this one right here, just for fun, I call it the Donkey Theorem. And the Donkey Theorem lies. All right, we'll talk about that more next time. All right, so now we're going to use those 5 theorems. And remember the 2 that don't work. Okay, so don't get those mixed up. So we're going to use those 5 theorems, and we're going to see which of these triangles are congruent, and then we're going to write their congruent statement. So I know that angle B and angle D are both 1s because they're both 90. I'm going to call this one a 2, and I'm going to call this one a 2. So I have 2 angles. I have an angle and an angle, and I have a side that does not connect. So this is side, 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 so I need 3 sides. I don't have 3 sides. This would be 2 sides and an angle. I don't have 2 sides and an angle. I have 1 side here and 1 side here. So is the S in the middle or at the end? So see how the S does not connect? So that means it has to be the one at the end. So this would be angle, angle, side. Okay, now this one, see how they give me 3 sides and 3 sides? This one should be super easy. When you see 3 sides, it's always side, side, side. Okay, now this one, they give me 2 sides and an angle, but that angle happens to be a right angle. So I don't want to use angle side, side because that's the Donkey Theorem, and remember the Donkey Theorem doesn't work. So since it's a right triangle, this is a leg, and this is a hypotenuse. So I can use hypotenuse leg. Okay, now this one down here, see how they give me 2 angles? And see how if I were to connect those 2 angles together, that's that side right there. If I connect these 2 angles with that side, so since the side is the one that connects the angles, then that one is your angle side angle. So this one would be angle side angle because the S connects your angles. And now this one, they give us 2 sides. So 2 sides. And then the angle that's in between. So this one would be side, angle, side. And that's an example of each one. So now let's go back and look at triangle 4. So triangle 4, they've got A, B, C. So I'm going to erase this so I can look at it. So A, B, C. So A, B, C. So since my B is a 2, then I'm going to label the F as a 2. Oops, sorry, my D is a 2. And since C is a 3, I'm going to label the F as a 3 because they have the same mark. So that means A is 1 on both. So if I have to go 1, 2, 3, then I have to go 1, 2, 3. So triangle A, D, F. So number 5, they're looking at triangle CAB. So CAB. So that's how I'm going to look at that, CAB. So since CA is the side with 2 marks, I'm going to go DE. So that's 1, 2, 1, 2. So that means F is 3. So that means this one is DEF. Triangle DEF. Okay, now 6. They're looking at JIK. So JIK. K. Since they labeled the J the 90-degree angle, then F is 1. To go across the 2 marks, I got to go across the 2 marks. 2, 3. So once you figure out your 1 and your 2, the 3 is easy. So if J, I, K, then I got F, E, G. Okay, now this one, let me erase my mess here. Okay, so they are saying CAB, CAB. So C has 1 mark, so F has 1 mark. A has 2 marks, E has 2 marks, so that means D is 3. So if CAB, then I got to go FED. See how the letters make it, or the numbers help keep the letters together? Okay, and now we've got triangle. So erasing my mess again. Go back here. They got NPQ. NPQ. So since P is the 90-degree angle, then I'm going to label X with a 2. See how PQ has 1 mark and XW has 1 mark? So that makes that one a 3. So then V gets 1. So this one, if it's NPQ, then it's VXW. All right. So now let's determine the shortcut. So all we have to do is determine the shortcut on this one. So they give me an angle and an angle, because there's 2 triangles here. Then I have this angle and this angle. So notice that they both share the same side. Well, I'm going to mark that because this triangle shares PR, but so does this triangle. So remember, PR is congruent to itself because it's reflexive. Remember that property? So now, isn't that a side? So that means I have a side that connects my 2 angles. So angle, side angle. Okay, now this one, this side is congruent to this side. This side is congruent to this side. And this piece is always equal to itself. So that's a side. So this one is side, side, side. All right, they give me a side, and they give me a side. They give me an angle, and they give me an angle. Now remember, this angle is equal to this angle because they're vertical. Okay, so now I've got 2 angles and a side that doesn't connect. So this would be 2 angles and a side that doesn't connect. Okay, now this one over here, I've got an angle and an angle. I've got a side and a side. And then right angles are always equal to each other. So this time I've got 2 angles and the side that connects. So I've got 2 angles and the side that connects. All right, now here, if you'll remember, let's refresh. We've got 2 parallel lines and the lovely transversal. So that means this angle is equal to this angle because they're alternate interior angles. Alternate, spell it right, exterior angles. Okay. Now these 2 sides aren't congruent, but this side's congruent to itself. So now I've got this angle, this side, and this side. Oh, that's an angle side side. That's the Donkey Theorem. That one's not going to work. So we're going to write NP for not possible. Okay. Now this triangle down here, this one is side, angle, side. But this one isn't. This one doesn't say side, angle, side, so they don't match. So I'm going to make myself a note here. They don't match. All right, so anytime I have vertical angles, that's automatic, or if they share a side, that's always automatic. So in this particular problem, I have an angle, and I have a side, and I have a side. Angle, side, side. See how this angle doesn't go between? So this one is not possible also, because you can't have the Donkey Theorem. So I'm going to write Donkey Theorem here. Donkey Theorem lies. All right, so now last one. We have an angle and two sides. Here I have an angle and two sides. They match again, but what's the problem? The Donkey Theorem lies. So we want to make sure that we understand that angle side side does not work. The end. See you guys next time. Later.